The topic of this video is identifying the turning points and end behavior of a polynomial function. Let's look at a problem. For f of x equals 5 parenthesis x squared plus 9 close parenthesis open parenthesis x minus 4 close parenthesis cubed. Part C, determine the degree and maximum number of turning points. Part D, determine the end behavior. Okay, let's begin with Part C, determining the degree and the maximum number of turning points. Remember that there are two ways to calculate degree. One way is to multiply all of these things out, and then the degree would be the largest exponent of x. The other is to use the theorem. In this case, the theorem is the faster path to determining the degree. For example, f of x can be written in expanded factored form as 5 times x squared plus 9 times the first x minus 4 times the second x minus 4 times the third x minus 4. Each one of these 5 factors is a polynomial. So I can write poly, 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 and the degree of each one can be written. So this is degree 1, 1, 1, 2, 0. And by adding up all of the degrees, it tells us that f of x is a polynomial of degree 5. Okay, wonderful. So we've now determined the degree. Let's determine the maximum number of turning points using our math elevator. Now that we know that the degree is 5, we will put the D car on the 5th floor, degree of 5. So what is the maximum number of turning points? Where can the T car go? Well, it can be at 0, 1, 2, 3, or 4, and therefore the maximum that it could be would be at 4. So the maximum number of turning points is 4. All right, part D, determine the end behavior. Well, there are also two methods that can be used to determine end behavior. These were specified in a previous video. Option 1 is when your polynomial is in polynomial form in descending order, in which case the end behavior is the leading term. But our problem is not in polynomial form, it's in factored form, which is option 2. So our leading term can be found by multiplying the leading coefficient by a power of x whose exponent is equal to the degree of the polynomial. Let's see if we can illustrate this visually. This is the leading coefficient, 5, and we know that the degree of the polynomial, by coincidence, also happens to be 5. Therefore, the leading term is going to be the coefficient of 5 multiplied by x raised to some power, and that power is going to be the degree of the polynomial. If you were to multiply all of this out, your highest degree term would be 5x to the 5th. This is the end behavior. The only thing we need to do now is put a y equals in front of it. The end behavior is the leading coefficient times a power of x whose exponent matches the degree of the polynomial. Okay, we have completed this problem.